As the Secretary General of the United Nations, an organization of 147 member states who represent almost all of the human inhabitants of the planet Earth, I send greetings on behalf of the people of our planet. We step out of our solar system into the universe seeking only peace and friendship, to teach if we are called upon, to be taught if we are fortunate. We know full well that our planet and all its inhabitants are but a small part of this immense universe that surrounds us, and it is with humility and hope that we take this step.
Many people remember exactly where they were when humans first set foot on the moon. But for those of us born after 1969, we've got to hang on to other epic moments in spaceflight history. I vividly remember watching the first launch of the space shuttle when I was 9 years old. And I remember when NASA's Voyager spacecraft swept past each of the outer giant planets in the solar system: Jupiter, Saturn, Uranus, and Neptune. It's been nearly 40 years since the Voyagers blasted away from Earth on their voyage into interstellar space. And here's the most amazing part: they're still operational, still working hard to deliver us science from the outer solar system. As I record this video, Voyager 1 is the most distant object ever created by human beings, more than 20 billion kilometers away from Earth, more than 4 times the distance to Pluto. And here's the really mind-bending part: Voyager 1 is the farthest object we know of in the entire solar system. But I'm getting ahead of myself. It's time to look back nearly 40 years and remember the Voyager missions and their amazing accomplishments over the decades. The Voyager missions were developed in the early 1970s to take advantage of a rare alignment of the giant planets in the solar system. With the right launch speed, trajectories, and planetary slingshots, it could be possible to send a spacecraft past each of the large planets in the solar system: Jupiter, Saturn, Uranus, and Neptune. Over the course of their primary mission, the spacecraft were to visit Jupiter and Saturn. But the mission controllers couldn't help but add Uranus and Neptune to the list, reprogramming the spacecraft as they explored the solar system to continue onward. Between them, the twin spacecraft observed 4 planets, 48 moons, as well as the rings and magnetospheres. Their original mission should have only been 5 years, but they were extended to 12. And now, almost 40 years later, they're still going and going. Voyager 2 lifted off first on August 20th, 1977, with a trajectory that gave it the option to add Uranus and Neptune later on its trip. Voyager 1 went second on September 5th, 1977, but followed a faster, shorter trajectory. Their first destination was Jupiter, the largest planet in the solar system. Voyager 1 arrived at the giant planet on March 5th, 1979, passing within a few 100,000 kilometers of Jupiter's cloud tops. It observed the incredible storm systems in Jupiter's upper atmosphere and helped to discover that Jupiter, like Saturn, has a ring system. Perhaps the biggest discovery at Jupiter was with its moons. The Voyagers discovered that Jupiter's innermost large moon, Io, has active volcanoes, spewing lava high into space. The first time volcanism had been seen anywhere else in the solar system. They observed cracks on the surface of Europa and Ganymede, indicating that both worlds have some kind of subsurface ocean beneath an icy crust. Between them, the two spacecraft took more than 33,000 pictures of Jupiter and its moons. Next up was Saturn, and in my opinion, the highlight of the whole Voyager program. Although the ring planet had already been visited by Pioneer 11 in 1979, the Voyagers took things to the next level. Voyager 1 arrived in November 1980 and sent back high-resolution images of Saturn, as well as its moons and rings. Voyager 1 was selected to make a closer flyby of Titan, Saturn's largest moon and the second largest moon in the solar system. It discovered that Titan's atmosphere is mostly made of nitrogen, like Earth. Unfortunately, it was too dense to see down to the surface. We'd need to wait for Cassini to show us what's down there. Voyager 1 discovered that Saturn's upper atmosphere seems to contain less helium than scientists were expecting, which indicates that the helium is slowly sinking down into the center of the planet. Voyager 2 arrived 9 months later in August 1981. It passed within 41,000 kilometers of Saturn and made even more observations of the planet and its environment. Together, the Voyagers provided the first tantalizing hint of geysers emanating from Enceladus, which Cassini confirmed decades later. And together, they discovered the huge hexagonal vortex at the planet's North Pole. At this point, the Voyagers parted company. Voyager 1 continued on from Saturn with no more destinations, while Voyager 2 performed a slingshot maneuver that put it on course to visit the outer ice giants. Voyager 2 still had 2 more destinations to go. Its next destination was Uranus in January 1986, when it passed within 81,500 kilometers of the planet. This was the first, and so far last, time that any spacecraft has ever reached Uranus. These are the only close-up pictures that we have of Uranus and its moons, thanks to Voyager 2. The spacecraft made several new discoveries about Uranus. The planet was flipped over onto its side by some collision in the ancient past, and Voyager discovered that not only does Uranus have a magnetosphere, but it's twisted into a corkscrew shape that trails behind the planet as it orbits the sun. Voyager 2 observed the planet's rings and collection of moons, but perhaps the strangest discovery was its moon Miranda. Voyager 2 observed huge cracks and canyons on the surface of Miranda as deep as 20 kilometers. Is it possible that the moon was smashed up in the ancient past and then reformed from the shattered pieces? The final stop on the grand tour was Neptune, visited by Voyager 2 in the summer of 1989. I remember this image vividly on television and in the newspapers. It was the summer I graduated from high school. Voyager 2 passed just 4,950 kilometers above Neptune's North Pole, closer than any other object during its voyage. Since this was Voyager 2's last stop, NASA was willing to throw caution to the wind. The spacecraft discovered that the winds on Neptune blow faster than anywhere else in the solar system, triple the speed of Jupiter. It discovered that the planet has storms swirling across its surface like the other giant planets. It fine-tuned estimates of Neptune's mass, discovered 6 new moons, and observed its ring system up close for the first time. And perhaps the most tantalizing was the close-up images of Neptune's moon Triton, a bizarre moon that dominates the Neptunian system and orbits backwards from all the other large moons in the solar system. Scientists think it was a captured Kuiper Belt object stolen in the ancient past. With Triton in its rearview mirror, Voyager 2 carried on, out into deep space. The grand tour was over, but the Voyagers still had more science to do, and we'll talk about that in a moment. But first, I'd like to thank Anton Velazny, John Clark, Alex Boissel, and the rest of our 765 patrons for their generous support. If you love what we're doing and you want to get in on the action, head over to patreon.com/universetoday. In August 2012, the spacecraft officially made the leap to interstellar space. escaping the sun's heliosphere. Now, in case you're not familiar, the heliosphere is a region of ionized plasma that surrounds the sun, blown out into space by the solar wind, like an inflated balloon. This bubble is what separates the sun's solar wind from the collective solar winds of all the other stars in the Milky Way. And the Voyagers crossed the region dominated by the sun into interstellar space. Even though Voyager 1 is now more than 20 billion kilometers away, it still emits signals of about 23 watts, about as much power as a refrigerator light bulb. Although by the time they reach Earth, they're a billion of a watt. And yet, they continue onwards. Now, let's look into the future. What happens next for these spacecraft? At their current pace, they'll reach the Oort cloud in about 300 years. That's the huge cloud of icy objects thought to surround the solar system and be the source of the long-period comets that we see from time to time. Unfortunately, they'll be dead much sooner than that, sometime in the next couple of years, as the radioisotope thermoelectric generator that powers the spacecraft isn't going to be able to give it enough electricity to keep its equipment going. The gyroscopes that allow NASA to reorient the spacecraft will cease operations. The data recorders will shut down. And in 2020 or so, NASA will start to shut down their scientific instruments one by one as the power levels continue to decline. Finally, by 2025 to 2030, the Voyagers won't have enough electricity to do anything else. We got 40 years from them, but we'll be lucky to get 50. And then they'll continue to drift off into the darkness. Their journey through the Oort cloud will last 30,000 years. And in 40,000 years or so, they'll get within a couple of light years of the star Gliese 445. But the Voyagers were built to last. Each was equipped with a golden record containing sounds and images selected by Carl Sagan and others. Aliens who encounter the Voyagers will enjoy the sounds of Earth, like whales, surf, and the wind, as well as musical selections. Oh, and a handy map to Earth using pulsars. The records were made of gold and etched with a sample of uranium-238, which has a half-life in the billions of years. Future alien civilizations could use this to determine when the Voyagers were constructed. Now, Anne Druyan, the co-creator of Cosmos, says that the records themselves will be playable for 1 billion years. The Voyager spacecraft were some of the most ambitious robotic spacecraft humans ever built. They carried our senses out to Jupiter and Saturn, and then Voyager 2 helped us see Uranus and Neptune for the first time ever. We still depend on and reference the images and observations from these hardworking spacecraft for so much of our understanding of the outer solar system. I'll miss them when they're gone. What about you? Do you have any nostalgic memories about the Voyager spacecraft? Let me know your thoughts in the comments. In our next episode, we look at the Van Allen belts, the radiation that surrounds the Earth, another dangerous hazard that astronauts face as if they need any more ways that the universe is trying to kill them. That's next time. Of course, I got a playlist of videos about the Voyager missions. First up, a video from NASA a few years ago when Voyager 1 reached interstellar space. Tom Scott visits the Voyager control room at NASA. Vsauce has a message for the future, including Voyager's Golden Record, and then a pair of longer lectures from NASA's scientists working with Voyager. And that starts right now.